Welcome everyone. Question number 301. In rolled steel beams, the failure of wave occurs at the concentrated loads and at the supports. Option A and B both are correct. So option D is right answer.
A heavy concentrated load produces a region of high compressive stresses in the wave, either at support or under the load.
Question number 302. In wave crippling, local buckling of the wave occurs immediately adjacent to a concentration of stress.
Wave crippling is buckling of the wave caused by the compressive force or concentrated load delivered through the flange to keep the bearing stresses within the permissible limits. And this wave crippling can be eliminated by bearing stiffener, and also thicker wave can be provided to eliminate this.
Option A is right answer correct. Question number 303. The allowable bearing stress for rolled steel beam is 189 Newton per millimeter square. Option C is right answer. Question number 304. The wave crippling is a failure of wave in direct crashing under concentrated load, right? The wave crippling means the stress concentration due to bottleneck condition at the wave toe of the fillet under or over heavy load concentrations, right? Option C. Crippling is a localized bearing stress caused by the transmission of compression from the comparatively wide flange to the narrow wave, right? Option D is right answer, all of the above. Question number 305. The bearing length of wave capital B under concentrated load is given by capital B equal to small b plus 2 into small h into root over 3. Option C is right answer, where small b is the length of the bearing plate and small h is the depth of the root of the fillet from the outer surface of the flange. Question number 306. An out of plane wave distortion is known as wave buckling, vertical wave buckling, column buckling. Option D is right answer, all of these. Question number 307. The failure of a wave in which the wave vertically above the bearing plate at the reaction or below a concentrated load is subjected to a column action and tends to buckle under it is known as wave buckling, vertical wave buckling, column buckling. Option D is right answer, all of these. Question number 308. The slenderness ratio for the portion of wave acting as a column when the two flanges are restrained against lateral displacement and rotation is equal to root over of 3 into small h divided by small tw, where h is the clear depth of wave between the root fillets and tw is the thickness of wave. Option B is right answer. Question number 309. The slenderness ratio for the portion of wave acting as a column when the top flange is held in position only while the bottom flange is restrained against lateral displacement and rotation is equal to root over of 6 into small h divided by small tw. Option D is right answer. Question number 310. A beam that is safe in wave crippling will not be safe in wave buckling.
Wave buckling is the deformation at the center of the cross section, and wave crippling is the deformation under the load at the support of the cross section. As per IS code, if the beam is safe in wave crippling, it will also be safe in buckling. So option B is right answer. Disagree.
Question number 311. Wave crippling occurs due to failure of wave under concentrated load. Option B is right answer. Question number 312. The wave crippling and wave buckling may be prevented by increasing the thickness of the wave. Option A is right answer. Question number 313. In the riveted built-up beams, an allowance of about 10% of the area of the cover plate is added to the calculated area. Option A is right answer. Question number 314. The area of cover plates in one flange capital AP of a built-up beam is given by AP, capital AP equal to capital Z minus Z1 divided by small d. Option B is right answer, where capital Z is the required section modulus of rolled beam section and capital Z1 is the section modulus of the rolled beam section and small d is the distance between the centroid of the top and bottom flange plates. Option 315. The load on a lintel is considered as uniformly distributed load if the masonry above the lintel is up to a height of 1.25 times the effective span. Option C is right answer. Question number 316. The rise of the jack arch is kept about 1/8 to 1/12 of the span. Option A is right answer. Question number 317. Which of the following statement is correct in connection with designing of jack arch roof? Option A. The deflection of the beam should not exceed 1 by 480 of the span, right? Option B, the thickness of the arch shall not be less than 10 centimeter, right? Option C, the spacing of the tie rods should not exceed 20 times the width of the rolled steel beams, right? Option D is right answer, all of the above. Question number 318. The horizontal thrust capital T on the tie rods provided at the end beams of jack arch is given by. Option D is right answer, capital T equal to capital W into L divided by 8 into capital R, where capital W is the live and dead load per meter length of the arch, capital L is the span of the arch, and capital R is the rise of the arch. Question number 319. When a beam is connected to a stanchion by means of two angles riveted to them, the connection is known as framed connection. Option C is right answer. Question number 320. Match the correct answer from group B type of connection and for the statement given in the group A type of beam. So in group A type of beam, option A, to permit large angles of rotation and to transmit negligible moment, we use seated connection. Option capital D. In group B, in group A, option B, to allow small end rotation and transmit appreciable moment, we use semi-rigid connection. Option capital A in group B. Option C in group A, when a beam is connected to a beam or stanchion by means of an angle at the bottom of the beam which is soft riveted to the beam, and an angle at the top of which is field riveted, is frame connection. Option capital B in group B. Option D in group A, when a beam is connected to a beam or stanchion by means of two angles riveted to them, we use flexible connection. Option capital C in group B. Question number 321. The unstiffened seated connection are used to transmit end reaction of the beam up to 150 kN. Option B is right answer. Question number 322. In designing unstiffened seated connection, the length of seating angle is assumed to be equal to the width of the flange of the beam. Option A is right answer. Question number 323. The stiffened seated connection are used when the end reaction of the beam is less than 200 kN.
No, 150
Option
kilonewton.
Option B is right answer, false. Question number 324. In designing stiffened seated connection, the outstanding of the stiffener angle should not exceed 16 times its thickness to avoid local buckling of the angles. Option D is right answer. Question number 325. In small moment restraint connection, if the pull on rivet is capital P and gauge distance for connected leg angles is small g and the thickness of the angle is small t, then bending moment capital M to be resisted by the angle for a single cantilever flexure is equal to. Option B is right answer, capital P into root over within bracket small g minus small t. Question number 326. In the above question, the bending moment to be resisted by the angle for double cantilever flexure is half of the bending moment for single cantilever flexure. Option A is right answer, correct. Question number 327. The steel beam of light section placed in plain cement concrete are called filler joists. Option C is right answer. Question number 328. Which of the following statement is wrong? Option A, when a filler joists are continuous over more than two supports, then these are called discontinuous filters.
No continuous filters.
Option B, when filler joists spans between two main steel beams only, then these are called continuous fillers.
Right.
Option C, the continuous fillers are connected to main beams by means of cleat angles.
Right. So option A is wrong.
Question number 329. The span of continuous fillers are considered approximately equal when the longest span does not exceed the shortest span by more than 15%. Option C is right answer. Question number 330. The bending moment for filler joists near the middle end span is WL square by 10. Option A is right answer, where small w is the dead load plus live load per unit length of the span and capital L is the span center to center of the support. Question number 331. The spacing of filler joists center to center should not exceed 9 times the minimum thickness of the structural concrete slab having imposed load up to 2500 Newton per meter cube. Option D is right answer. Question number 332. When the underside of the concrete is arched between the filler joists, the thickness at the crown should not be less than 50 mm. Option A is right answer. Question number 333. The span of the filler joist center to center of the support should not exceed 35 times the depth from the underside of the joist to the top of the structural concrete. Option C is right answer. Question number 334. In case of cantilever fillers, The span of pillar joist center to center of support should not exceed 12 times the depth from the underside of the joist to the top of the structural concrete. Option A is right answer, correct. Question number 335. The rolled steel section used in cased beam has width capital B mm and diameter capital D mm. The minimum width of the finished cased beam is given by capital B plus 100 mm. Option B is right answer. Question number 336. Which of the following statement is correct? Option A. Plate girders are deep structural members subjected to transverse loads. Right. Option B. Plate girders consist of plates and angles riveted together. Right. Option C. Plate girders are economically used for spans up to 100 mm in construction. Right. Option D is right answer. All of the above. Question number 337. The vertical plate of a plate girder is termed as wave plate. Option A is right answer. Question number 338. A wave plate is called stiffened when the ratio of clear depth to thickness of wave is greater than 85. Option D is right answer. Question number 339. The distance between CG of compression flange and CG of tension flange of a plate girder is known as effective depth. Option B is right answer. Question number 340. In general, the depth of plate girder is kept as 1/10 to 1/12 of the span. Option C is right answer. Question number 341. The clear depth of a plate girder is the distance between the vertical legs of the flanges angles at the top and at the bottom in case of horizontal stiffeners are not used. Option C is right answer. Question number 342. When the depth of the plate girder is less than 75 cm, then such girders are known as shallow plate girders. Option B is right answer. Question number 343. A steel welded plate girder is subjected to a maximum bending moment of 1500 kN if the maximum permissible bending stress is 165 kN per millimeter square, then the most economical depth of the girder will be. We know economical depth of plate girder D equal to 1.1 into root over of m by sigma b into Tw, where m is the bending moment in the plate girder, sigma b is the allowable bending stress, and Tw is the thickness of wave plate. Assume the thickness of wave plate Tw equal to 10 mm. Okay, because this is not given. So if we calculate and put all the value, we will get the economical depth D equal to 1048.74 mm, nearly 1000 mm. Option C is right answer, 1000 mm. Question number 344. The economical depth of the plate girder is defined as the depth which gives minimum weight of the plate girder. Option C is right answer. Question number 345. When the depth of a girder is at least 8 times the depth of the vertical leg of the flange angles, such girders are known as the shallow plate girders. Option B is no. Question number 346. In a plate girder, if capital M is the maximum bending moment, sigma b is the allowable bending stress, and small t is the thickness of the wave plate, then the economical depth of plate girder small d is equal to 1.1 into root over of capital M by small t into sigma b. Option B is right answer. Question number 347. The weight of a plate girder varies 1% for 10% variation in depth of girder. Option B is right answer. Question number 348. The economical depth of a plate girder is assumed 15 to 20% less than the calculated value. Option A is right answer. Agree. Question number 349. For all practical purposes, self weight of the girder is taken as capital WL by 300. Option C is right answer, where capital W is the total superimposed load and small l is the length of the plate girder in meters. Question number 350. According to Whitar and Clark formula, the economical depth of wave plate of a plate girder is approximately equal to 4.5 into within bracket capital M by sigma b to the power 1/3. Option D is right answer, where capital M is equal to the maximum bending moment and sigma b is the allowable bending stress. Question number 351. As per IS 800 1984, the maximum thickness of a plate girder wave plate should not be less than d by small d by 200 for vertically stiffened waves, where small d is the clear depth of plate girder. So option B is right answer. Question number 352. The diagonal buckling of wave in a plate girder occurs when the ratio of clear depth to the thickness of wave exceeds 85. Option A is right answer, true. Question number 353. Bearing stiffeners are used in a plate girder to avoid local bending failure of the flange, right? To avoid local crippling and crashing of wave, right? To under concentrated loads and at the points of supports, right? So option D is right answer, all of the above. Question number 354. In a plate girder bridge, the thickness of wave is less than small d by 200, where small d is the unsupported depth of the wave, and the wave plate should be provided with vertical stiffeners. Option A is right answer. Question number 355. When the torsional resistance at the ends of the plate girder is provided only by stiffeners, the moment of inertia of the stiffeners about the center line of the wave shall not be less than small d into small t divided by 250 into capital R by capital W. Option A is right answer. While small d is the overall depth of the girder, small t is the maximum thickness of the compression flange, capital R is the reaction on the bearing, and capital W is the total load on the girder. Question number 356. In a plate girder, the vertical stiffeners are provided when the ratio of clear depth to the thickness of wave exceeds 85. Option D is the right answer. Question number 357. Which of the following statement is wrong? Option A. Vertical stiffeners are also termed as transverse stiffeners, right? Option B. When two angles are used for the vertical stiffeners, then they are provided on either side of the wave, right? Option C. When the single angle is used for the vertical stiffeners, then they are placed alternatively on opposite sides of the wave, right? Option D is none of the above statement is wrong. Question number 358. The allowable shear stress in stiffened waves of mild steel beams decreases with the increase in spacing of the stiffeners. Option B is right answer. Question number 359. In plate girders, the vertical stiffeners are provided at spacing not greater than 1.5 d and not less than 0.33 d, where small d is the distance between the flange angles.
Option D is right answer.
Question number 360. The length of outstanding leg of vertical stiffeners may be taken equal to 1/20th of the clear depth of girder plus 50 mm. Option B incorrect. Question number 361. A welded steel plate girder consisting of two flange plates of 350 mm into 16 mm and a wave plate of 1000 mm into 6 mm requires.
If we calculate the value of d by tw is between 85 to 200, so intermediate vertical stiffeners are to be provided. Option C is right answer.
Question number 362. Horizontal stiffeners in addition to vertical stiffeners are provided on the wave of a plate girder when the ratio of clear depth to thickness of the wave exceeds 200. Option D is right answer. Question number 363. Intermediate vertical stiffeners are provided in plate girder to eliminate wave buckling. Option A is right answer. Question number 364. A typical section of a crane girder is shown in the figure 15.18. The function of the top channel is to increase the torsional stiffness, increase the lateral buckling strength, increase the moment of inertia about the vertical axis. Option D is right answer. All of the above. Question number 365. At a section along the span of a welded plate girder, when the wave is spliced, the bending moment is capital M. If the girder has top flange, wave and bottom flange plates of equal area, then share of the bending moment which would be taken by the splice planes would be capital M. Option A is right answer. Question number 366. Horizontal stiffeners in plate girders are used to prevent local buckling of the wave. Option C is right answer. Question number 367. At least one horizontal stiffener should be placed in the plate girder in which the thickness of the wave is less than small d by 200. Option A is right answer, where small d is the depth of the wave. Question number 368. Intermediate vertical stiffeners in plate girders need to be provided if the depth of the wave exceeds 85 into Tw. Option B is right answer, where Tw is the thickness of the wave. Question number 369. Gantry girders are designed to resist lateral, longitudinal and vertical loads. Option D is right answer. Question number 370. The vertical stiffeners in plate girders are provided to prevent local buckling of the wave. Option C is right answer.